Hi everyone, my name is Zinkler and today I'm going to be doing my Term 1 project on convergent plate boundaries, which is the oceanic and continental plates. For this I'm going to be using Greek yogurt to represent my asthenosphere. So, let's put that down. Slightly so you can be centered. Right, so I got Greek yogurt to represent my asthenosphere. I got fruit roll-ups, which is going to represent the oceanic plates or oceanic lithosphere. And oops, 1 second. Gotta get these babies. And I got graham crackers, right? Which are going to represent my continental plate or continental lithosphere. Now, because when both these plates are colliding, the thinner and more dense oceanic plate is going to be forced down by the thicker and less dense continental plate, just like so. This process in which the oceanic plate is being forced down into the mantle is called subduction, which looks like this. Right? As you can see, oceanic plate has been subducted underneath the continental plate. Now, when the oceanic plate subducts, it goes deep into the asthenosphere where temperatures are getting higher. This causes the plate to start melting partially. When this happens, it produces magma chambers. Above the subducting oceanic plate, which you can kind of see over here. Now remember, this is going to keep going further and further and further. And as this keeps on happening, the oceanic plate is going to go deeper and deeper into the asthenosphere. Now, the magma chambers slowly begin to ascend through the lithosphere and through the continental crust. And the size and depth of the magma chambers can be determined by seeking the activity around them. By seeking the earthquake activity around them, Over time, if the magma still does not solidify, then it will break through the continental crust in form of a volcanic eruption. So, break. Let me show you. As I said, over time, this will form into break and a volcanic eruption. And as you can see, magma has risen up over here and has cracked through the continental plate. An example of this type of convergent boundary is in the Washington-Oregon coastline of the United States. Here, the westward moving North American continental plate, the Juan de Fuca oceanic plate, is subducting. A chain of volcanoes above the melting oceanic plate is the Cascade Mountain Range. Another example of this is a convergent boundary between an ocean and a continental plate is the Andes Mountain chain, just west of South America, and the Nazca plate, which subducts underneath the South American plate. Now, results of a convergent boundary between an oceanic and continental plate include an area of earthquake activity that is shallow along the margin of the continent but deepens underneath the continent. An ocean trench is also directly off the continent shore. This is because as the oceanic plate keeps on subducting more and more, you have this whole line of where they connect. This is then known as the ocean trench. You also have a string of volcanic eruptions a few hundred miles from the shoreline inland. Now, because, remember, the oceanic plate and the continental plate are moving towards each other, this is going to go deeper, the oceanic plate is going to go deeper and deeper, and this is going to move inwards. Along this line, you're going to have volcanic arcs, and these are all going to eventually, or some may never, but most likely erupt because of the amount of magma chambers that are rising. As well as another effect of conversion and boundaries, and another effect of a conversion boundary between an oceanic and continental plate is also the destruction of oceanic lithosphere, which again is, just to reiterate, is when the oceanic plate is subducting underneath the continental plate. And this destruction is where this little guy is going to be melting as it goes deeper and deeper into the lithosphere. Thank you for listening to my presentation. I hope you enjoyed and I hope you understood everything I was trying to get through. Thank you.